I have been programming computers since the 5th grade, and that's not an understatement. I taught myself how to program them in the 5th grade using books from the library. I know, old technology here. I've always had hardware to work with ever since, right? So essentially a home lab, although, of course, at this point, there's a lot more in it than the first computer I started on. And it's pretty great at this point, if I do so say so myself. But it didn't need to take as long as it did for me to get to this point in time. And that's my goal here. I, I want to share some ideas and possibly help to influence your home lab to get to a better place sooner than later. And I have this slide here because I don't want you to panic. I may use words that you've never heard before, right? Whoever's searching YouTube for a video that's talking about a home lab, you could be at any point, right? You could be right at the beginning wanting to set something up. You can be a little more intermediate because you're looking for something in particular. And there's a wide range there where this video will be really good. It's good even if you're just starting out. But I want you to be sure not to freak out if it seems like I'm talking about a lot of things that you don't know about, because all I'm really trying to do here are to share the current state of where things are for me. And if you hear a word that you haven't heard before, you might Google it. You might just decide to implement that into your lab environment. And hopefully the outcome is that we all as a group, get further along, and you don't have to just like find something, over the course of your technical career where you say like, oh my gosh, I could have done this like 10 years ago, but nobody I knew was doing it, and I didn't happen to type it in Google to see it. It just took a point in life to run into somebody who was using it, right? And you're like, well, at least I found out eventually. But I want you to find out now. All right, let's get started. So here's our overview. And VLANs, right? So it's like a virtual LAN. And I'm going to tell you about a firewall product that I'm using, Palo Alto, or you can use like pfSense, even some off-the-shelf solutions like something a Wi-Fi router that you would pick up at Best Buy can support VLANs. If you've never thought about VLANs, even if you've gone into your router, you might not have noticed that the VLANs were there. So you might take a look to see if it's supported in your environment. But you want to use VLANs eventually because it helps you to keep things organized. And you can see what we're doing here. We've got a server network, a storage network, a client network. And they're going to have machines living on each of these VLANs, kind of separated by purpose. And then we're also going to talk about Kubernetes a little bit because from this point forward in time, this is probably the main technology going forward for like at least 10 years. And somebody else might have a different Kubernetes product, which is very similar to Kubernetes that might, take over. But I think there's a chance you might not have even heard of Kubernetes. So maybe this video could cause you to look into that. It's all I do at this point in my career. And you might want to as well. And we're going to set up VLANs specifically to deploy Kubernetes as well. So here we go, VLANs. So I'm going to demonstrate with a Palo Alto, but like I said, you might want to use pfSense. That's more of an open source solution. And you can still buy hardware for pfSense. You buy the hardware and then it comes with the solution, or you could just stand up your own hardware and install pfSense. But man, if you're not using something like Palo Alto or pfSense, and even if your current router can handle VLANs, look what you might be missing out on. This is a firewall and it's showing all the traffic in my home network, right? And this alone can be cool if you like data like this, like what's my computer talking to? And you can click on another page and it'll show you like where in the world your applications are talking to, like, oh, this application's talking with Russia. That's interesting. It's even possible to do some virus scanning, like inline. And you can even have it inspect packets, right? So you could like have your mobile app plugged into your Wi-Fi, which ends up going over the firewall, and you can set it up to be like a man in the middle. It'll pull apart the HTTPS and let you see what's happening, which is cool. You can like reverse engineer things. If you're a developer, that's probably the target audience for that. And if you're a developer and that sounds interesting to you, you can do it without a firewall. Okay. But this is also another way you could do it. And here's another screenshot. These are my VLANs. You see them there. They're like 1,000, 2,000, 2010, 2020. So what this is it in Palo Alto. Of course, it's going to be very similar in pfSense and very similar in your off the shelf solution if you go with that route. I'm telling you, you might want to at least look into these. It's just so cool what they're capable of. All right, so we'll do our initial like workflow here. We're just gonna pretend like nothing exists. How would you like, a general idea of the order you would install it? So I'm using a VMware solution. Use whatever you want to use, Proxmox, Zen Center, whatever. I'm going to talk about VMware because that's something I'm currently geeking out about. I never thought I would, but I needed to for work, so I ended up deploying it into my environment, and I ended up getting like the vMug, which is like $200 a month. Or $200 a year. It grows on you. Currently, it has grown on me, so that's what I'm using. I'm going to talk about it. First, set up like an ESXi host. I have 2 of them. Don't bother logging into them. Just like stand them up, and then deploy vCenter. So you might notice at this point, I'm not showing you any screenshots. I'm not walking you through it. I could make a video just for this purpose. And if you want me to, let me know in the comments. But these general guidelines, if it's interesting to you, right, go for it. Get these steps taken care of and then move on to the next. vCenter lets you manage the ESXi hosts. And with vCenter, after you stand it up, the first thing you're going to do is stand up a cluster, and you're going to add in the ESXi1 and the ESXi2. And from this point forward, just interact with vCenter. And the first thing you're going to do are set up a couple VMs. I recommend DNS1 here, DNS2. So in my case, I deploy out Linux, and then I install Docker, and then I deploy Pi-hole using a Docker container. And Pi-hole is my DNS server. Pi-hole allows you to filter out ads, right? So when you're browsing the web, if this is your DNS server, you'll get fewer ads in general. And there's more to it than just ads, right? But that's the main purpose. So it could change everything for you. And if you set up a VPN from your mobile into your house, into your home LAN, you can use the DNS servers at your house, and then your mobile won't have as many ads in it either. This is like game changing, I'm telling you. There was a point where I was about to create this solution myself because I wanted it so much. And then I came across an existing solution, very nice, and it works great. Every now and then you might see like an ad, and then you just wait a little bit, and it's as if people are out there maintaining it, right? So then the new stuff gets blocked again, and they're on top of it. This is a good product. Okay, we have vCenter stood up, and we got our 2 Pi-hole servers stood up. Next, we want to configure our VLANs on vCenter because we need to use these. As we stand things up, we need to select these as our network provider. So it's going to vary, depending on what virtualization you're using. But if you look at the right there, that's what it looks like in vCenter. So we have distributed switches, and underneath that, we have distributed ports. So the way that vCenter works, essentially you set up your port on one ESXi host, and that's going to be mirrored on the others, which makes sense, right? If you have a VM on one host and you want to essentially drag and drop it over, or using the DRS that it has built in, it's going to be easy to move that VM from one host to the other. If it's just memory and CPU, you can do it live. And as long as your storage is like remote storage, it's going to happen quick. But of course, you want the same network adapter set up on both ESXi hosts. And that's how vCenter does it. So these slides are not perfectly in order. I figure for anybody who's using this video, you're probably going to watch it more than once. I just wanted to talk about this before we do it. You can set up and Pi-hole conditional forwarding, right? So when we stand up our client network, we're going to have domain controllers in there, and they're going to have their own subdomain, right? So we're going to set up c.home.net. And the thing is, any machine in our entire environment, as long as they're using these root servers, if there's a domain that Pi-hole doesn't recognize, it's going to go out to the internet and pull it down, right? As long as it's not blocking the ad. So what if it's something in our home lab environment? Well, this will ensure that it forwards instead of out to the internet. It'll say, oh no, I want to use the domain controllers as my upstream servers. And this is how we're going to do it. And we're going to have another domain specific for apps that are running in Kubernetes. So we'll come back to this a little later. I just wanted to give you a heads up on the domain name. So as you set up the domain controllers, should you be planning to use the domain controllers, before you create your cluster and set the domain name, make sure to use a subdomain. It's going to be good, I'm telling you. All right, let's talk about storage. So the thing is, this is one of the things I wish I had done like 10 years earlier. Okay, you want to use remote storage. You don't want to use your local hard drives, even if it's like an NVMe, because of the situation I just mentioned in the last slide. If you want to move one VM from one machine to the other, you just want it to be CPU and memory. You want your storage to be remote so that it happens fast. But if you have, 10 VMs and they're all using that remote storage, you need to have fast network. Otherwise, you're going to notice, and it's not going to be a good experience. You do need to have like a 10 gigabit connection. So myself, for a while, I just connected the ESXi host together without a switch. You can do that. You still have to pay for the NICs, and they can be a little pricey. But yeah, you might plan for that. Buy the NICs, eventually get like a 10 gigabit switch, and then have your storage, your TrueNAS server, your ESXi hosts all plugged in to that fast network. You want the VM hard drives over a very fast network connection. And then just a heads up, later on we're going to set up Ceph, but we're going to do that ourselves. And then Ceph is a storage solution that's distributed. For home lab, that can be a little expensive, right, to have multiple machines. But using Ceph, it means if one of the machines crashes, everything's okay because it's making copies on the different nodes. TrueNAS doesn't do that. Once TrueNAS is down, it's down. But it's a home lab, so it's okay. Be sure to back things up. All right, so we just talked about TrueNAS storage. We're set up an NFS share over there, and then we're going to mount that within our virtualization solution. So here's a screenshot in vCenter doing just that. All right, and our client VLAN. So if you're not using Windows or you don't really have a client VLAN, you can just skip this one completely. For myself, I have a Windows machine, and I like to have them interact with the domain controller. So I've got a couple of domain controllers here on the client subnetwork. And you don't have to do this, but I put it here. You might want to set up a conditioning and forwarding rule in your domain controllers that also forwards over to the k.home.net. So you just have to do it right. Whether this Kubernetes domain forward is in the root core DNS servers that we set up, or you set it up here, or you set it up in both, you just have to get it right. Otherwise, the applications that you stand up in Kubernetes, you won't be able to get to them. So you'll realize that if you're not able to get to them. In any case, domain controllers can also do the conditional forwarding. And your clients, which you're going to stand up on your domain controllers using DHCP, they're going to use these domain controllers. So just mentioning it in case you wanted to have different DNS servers for these domain controllers, you would, if you did that, you'd have to set up conditional forwarding. I recommend just using those root DNS servers that we set up with Pi-hole. Then you get ad blocking. All right, here, and the one inconsistent server, I called it WB for Workbench. That's my Linux system. I probably should have called it Linux 1, but you end up typing it all the time because I love Linux, so I wanted a short host name, and you might do the same. The Linux system is a DHCP client. If you think of Linux as a server, you could put it on the server network and you could go to static IP. I'll let you make that call. Oh, for myself, I like to log in my Linux system using the username that I have set up on my domain controllers. That's why I have it as a Windows system client. All right, let's configure a little bit. So we've got our domain controller set up. We create a domain using c.home.net or whatever your domain is. Stand up a user there. That's where I set up my user account. And then what services are you going to use on Windows Server? Well, it's got a bunch, but I mean, the main thing is DNS, of course, especially if you're going to use PyKMS later, you'll have to register that in DNS, but you don't have to. You could always do this in your core DNS servers as well in the Pi-hole servers. I'll use DHCP with my Windows Server just so I can push out different values, the DNS server to use and whatnot. And for a long time, I did my own WSUS server, but you don't have to. I'll let that be your call. If you set it up, you'll have to configure it through your group policy object. And for a long time, I used it as my certificate authority, but then I switched over to using Vault. So Kubernetes, it's very standard to generate certificates on the fly, completely automatically. And when they expire, you can generate new ones. This is something you're going to get to later. In order to do that, you have to have a certificate authority. So yeah, you can use Windows for that. I eventually switched because the solution I was using became deprecated. You can still use it. It still works. But Vault is a pretty slick solution. One more thing to learn, right? One thing at a time. All right, and I just mentioned it here again, that you want to set up the DNS forwarding in your root DNS over to the domain that we've just talked about again, now that you got a little more detail. All right, the big thing, Kubernetes. So I, at one point, was invited to an interview, and it was not in the description that it was a Kubernetes position, but it was a job for Kubernetes. What the employer had done was post all of the skill set of a kind of person who would love Kubernetes. I mean, it was, and I get it, it was a good strategy. I didn't get the job, but I began pursuing Kubernetes afterwards. Like, what is this thing he was talking about? And as I discovered what it was, it just blew my mind. I'm like, oh my gosh, how can it be that I'm just learning about it? But if nobody is using it, who's around you, if your friends aren't using it, if it's not being used at work, there's a good chance you don't even know it exists. But that was it for me. And so I began pursuing it. And I mentioned at the beginning that I taught myself how to program for this reason. My entire life, every technology I've taught myself. And I began teaching myself Kubernetes to the point that I watched a YouTube video where I deployed a Kubernetes on my own manually using kubeadm. And I was successful, but I could tell at this point, I was like, this is a completely different world. And I took a class. There's an Udemy class, a CKA class with tests, practice tests. And it was like a perfect class. And I could feel my brain rewiring. Kubernetes is not something you necessarily want to just like pick it up as you go. It's probably good to take a class. You want to have a good experience. You don't want to feel overwhelmed. It's somewhat similar, I would say, to learning to program a computer. So if you've never programmed a computer and you were to learn a new language like Go, no big deal because you already know how to program. You're just learning a new language. But if you took somebody who'd never programmed a computer, even if they're a prime candidate for programming a computer, you probably want to put them through a class, right? I mean, they might be able to teach themselves, but it can be a lot to learn all at once. And Kubernetes could be a little similar in that it is a skill set. And, in the way you might put like Microsoft Word in front of somebody and say, just figure it out. You don't want to do that necessarily with Kubernetes. I recommend taking a class, but in any case, you can just deploy using like kubeadm, as I said. This technique with these VLANs is specific to this VMware solution I'm going to be talking about. So Tanzu wants you to set up 3 VLANs. We already talked about how to set up a VLAN, so we're just doing this configuration for Tanzu. Tanzu also wants you to deploy AVI, which is another VMware product, right? So if you're not using VMware, you don't install Avi, you don't need it. It's specific to Tanzu. Tanzu also has an HA proxy solution. I tried it. Don't do it. If you're using Tanzu, just go ahead and use Avi. And that's what we're going to do. But of course, you can use whatever virtualization solution you're using. After you've stood up Avi and after you've stood up your VLANs, you will be ready to deploy workload management, which is Tanzu. And Tanzu is essentially an enterprise offering of Cluster API. Cluster API allows you to stand up additional Kubernetes cluster. So you have to stand up the first Kubernetes cluster, install Cluster API to that Kubernetes cluster, and now you can use that cluster to stand up additional Kubernetes clusters. So there's a little bit of a chicken and egg thing happening here. And what I like about Tanzu is that it stands up that first Kubernetes cluster for you, essentially. VMware is like, use us. We'll just through a click of a button and configuring a few VLANs, now you have this initial cluster. They call it the supervisor cluster. And then you can use that cluster, which is essentially managed through vCenter, and use that to spin up additional clusters. So the chicken and egg situation is resolved. But of course, you can just stand up your own cluster and install Cluster API. Okay, so now we have Tanzu installed. And that's understatement of the year. if all these technologies are new to you, it might take a while to get to this point. No worries. But now we can deploy Kubernetes clusters. And I'm suggesting here to deploy a couple. You might just deploy one. I mean, we're using virtualization technology, right? So if you have 10 CPUs available and you deploy 4 VMs and they're each using like 4 CPUs, right? They're all going to work. Virtualization, right? So is there a big difference between deploying 2 clusters? They're all using the same CPU. I'm going to leave that up to you. You could just use one here, but just for sake of communication, I have a couple. I just want to say, though, that it's not one application per cluster. You deploy hundreds of applications into a cluster. All right, so I'm suggesting we have a couple of clusters running here now. Now we want to start deploying apps. So a little bit of a chicken egg here as well. So we want to use Argo CD to allow us to use GitOps to deploy our applications into the Kubernetes environment. This means infrastructure as code, and that code, which are YAML files, we're going to create those and store them into Git. And then we're going to point Argo CD at that Git repo, and Argo CD will ensure whatever's defined in that Git repo is reflected into the environment. So whenever you change something in the environment, you change it in Git. So everything is tracked, right? If somebody else is deploying something into your Kubernetes environment, it's trackable through Git. And it's also self-documenting. Once you know how to read like Argo CD files and you're able to use this Git technology, you can just go look into Git and see everything that's deployed into your environment. Imagine the same in the existing environment, which I call BK, right? BK before Kubernetes, AK after Kubernetes. In the BK environment, you might have like 100 VMs and things are running on them, but what's running where? Who knows? And what OS version is running on all those VMs, right? Now it's your job to manage all those VMs and all the OSs and all the security updates. And what about certificates? They're going to expire and you're going to have to manually install those certificates on all 100 VMs. Right? This is work. This is labor. In Kubernetes, if you go to a conference for Kubernetes, nobody's discussing certificates because that is a solved problem. You solve it in one way. It generates the certificates completely automatically. When they expire, it generates them again. There's no downtime. You don't have to mess with it. It's just done. It's fantastic. Right? Kubernetes is kind of like magic in a lot of ways. If you ever seen that movie, Tomorrowland, like what is that IT department running? They're definitely running Kubernetes, guaranteed. All right, so we stand up an Argo CD seed instance. We got to do that manually. This is going to solve the chicken and eggs scenario. Then we use that Argo CD seed instance to stand up Argo CD. So now we have Argo CD managing Argo CD. That first Argo CD seed instance, we have to manually like upgrade that over time. But after that, everything running in Argo CD is all managed through Argo CD and Git repos. All right, I'm not paid by Acuity, but I just wanted to mention here that the chicken and egg problem that I just discussed with you and a potential solution, there's a couple other ideas that might be better. There's a service in vCenter, and in the same way that we can use Tanzu to solve the chicken and egg problem around Cluster API, there is an Argo CD service that you can install as part of Tanzu. And you could use that Argo CD instance to manage your Argo CD instance. Uh, you might want to use the Argo CD instance provided by vCenter as your main Argo CD instance as well. Um, I like to be able to be in control of what version I'm using. But if you want to just trust VMware to manage that for you, I suppose you could. Additionally, there's a company, Acuity, who originally created Argo CD, and they continue to submit code fixes as well. And they offer an enterprise solution. You can have their enterprise solution either in the cloud or they have an on-prem solution as well. And you can work with them to solve that chicken and egg problem and just get Argo CD set up in all of the various ways that you might deploy it into your environment, either one big Argo CD up top or one Argo CD instance on each cluster. Opportunities are endless. All right, and then what's the first thing we do now that we have Argo CD running? Well, now we're able to deploy everything into Kubernetes. This is our starting point, right? And the first thing we're going to deploy is Ceph. And by doing it this way, using Ceph deployed to Kubernetes, using a cluster we just stood up, we now have multiple nodes in the way that Ceph wants, right? You could have like 3 or 4 VM nodes. They're all VMs, of course, and they're using the storage that's on TrueNAS, right? So if that TrueNAS server goes down, we're out of luck. Still, I mean, it's a home lab. Back your things up. But now we can have like 3 or 4 nodes in Ceph, and they're all using the remote storage. We need that 10 gigabit. But now you can still shut down your ESXi host, right? And DRS will just move everything over when you go into maintenance mode over to the other ESXi host. And because it's using remote storage, you can do like a live migration and now you can shut down that ESXi host. I mean, as long as you have enough CPU and memory, right, to move everything over. But it's designed to work and there's no downtime. And now that we have Ceph, we can use it to stand up a read write many PVC. All right, so we'll talk about that here. So you stand up Ceph, you configure an NFS share using Ceph, and now we add that NFS share as a data store option in vCenter and the workload management. And once you add it to the workload management, every Kubernetes cluster that you deploy will have this as an option for storage. All right, so just to recap, I'm not sure if I mentioned this before, but if you use read write once in a Kubernetes environment, that means read write once. That's one pod. And here's an example. Say you want to upgrade WordPress and you're using WordPress 1, and then you want to upgrade to WordPress 2. We're in Kubernetes. Okay. WordPress 2 stands up the container and it tries to reach the storage, the PVC, the read write once, but you can't access it because it's already in use. And the other the other pod, WordPress 1, it's like, well, I can't shut down yet because the new one's not ready yet. And they just sit there forever. But if you have read write many, the second one, WordPress 2 comes up, it connects to the network share. Oh, the PVC, read write many. Oh, we're good. We get to a ready state, and then the first pod says, oh, the new one's ready. We'll just go ahead and shut down. And now we've upgraded, and that's how you get zero downtime using Kubernetes. It's like magic when it works the first time. In BK world, there's a lot more to it. We all know how to do that, but it just happens in Kubernetes, like out of the box. It's so simple. It's fantastic. But it only works if you have read write many. And people told me in the past, and you'll encounter this as well as you get started, like, oh, just use NFS. It supports read write many. Those people have not done a lot of experiment. The file locking is not perfect in all the solutions. Yes, you can configure and set up a read write many, but if you use an application such as Nextcloud or Plex, the data will become corrupted. And those both use a technology, SQLite. And we don't want to just blame SQLite. I'm sure there's other issues with other problems. That's what I discovered the issue with. And it's that the file locking was not actually enforced. essentially two things want to write to the same thing. The NFS share is like, okay, yeah, go ahead. But it wasn't actually enforcing the file locking. Even if in the code you said, I only want to be the I want to be the only person who can access this. It it's not enforcing it, right? So the other things like, can I have access to it? And the NFS was just like, okay, sure, go ahead. Okay, anyways, so I, I did an I tried things that people told me would work. I tried NFS on TrueNAS. I tried iSCSI on TrueNAS. They both worked great, but they didn't work with read write many. And I tried several other things. I tried Longhorn, like Longhorn supports it, but then again, it was just using NFS behind the scenes with the exact same problem. But when I used Ceph, it was perfect, right? Something about the underlying infrastructure of Ceph makes it work. So even though Ceph is exposing it through NFS, that NFS share is now going to work perfectly with file locking because it enforces the file locking. Okay, and then we get read write many. All right, so we've talked that right into the ground. You don't have to, is what I want to communicate here. Even if you use read write once for like a year, I mean, it's your own home lab. So if a pod is stuck upgrading, you know what's going on. You just kill the old pod and the new one will come up. You'll be fine. But eventually you want to get to the read write many and zero downtime. And the only thing stopping you is storage. Of course, you could stand up your own Ceph server. You don't have to use TrueNAS at all if you have the money. All right, I'm going to take myself out of the picture. Okay, I've been to Toastmasters, so I'm not just going to read this whole thing to you. I'll talk about the first one, WireGuard. Uh, I'm not sure if I mentioned this or not, but you don't want to run that within Kubernetes. There's a kernel level module that works great with WireGuard. If you're running in Kubernetes, you need a lot of security permissions to interact with the kernel. You don't really want to do that unless you're trying to troubleshoot something. Instead, just run it on like one of the DNS VMs or on your Workbench VM. Otherwise, everything going forward, it's all running in Kubernetes. And these are a few things you're probably going to run into initially. All right. So, in summary, we got our VLANs. If you're not using those, let's figure them out. Firewall allows you to see what's going on in a way you can't even imagine it. You get over it eventually, but it's pretty cool. Initially, when you see all this stuff, you didn't even know you could see before. And if you're low on budget, I mean, it is a home lab. Your off the shelf wire router might let you do the VLANs. You won't get all the other cool features, but hey, you can at least start setting things up with VLANs. We need the 10 gigabit switch. Start budgeting. That's a game changer right there. Otherwise, you can't move VMs around between your two servers. And you want to have at least a couple servers because how else do you upgrade things? You're going to have to shut everything down to do the upgrade. And if you've got the budget, that's fine. You just do it. But eventually, you want to be able to move everything over, shut one down, stand it back up. Zero downtime's cool, even in your own home lab. And then we deployed a Ceph server, right? So we could do the read write many. And just to summarize the servers, these are what I call core VMs, things that have to be a VM, and everything else ends up running in Kubernetes. So these are just kind of the foundational things to get us to the point where you can use Kubernetes. And we want to use cluster API. So we're letting Tanzu be our first Kubernetes cluster. So we don't have to worry about cluster API. We just let VMware manage that. We have to stand up Avi because Tanzu requires it. Then we stand up Argo CD so that we can use GitOps and then Ceph, of course. All right. Good luck out there. I hope this has been inspiring and not something to cause you to freak out. All right. I hope this was useful. Thank you.